so we'll touch on box cutters. So box cutters, get poo-pooed a bit, but they make things possible. Basically, there are some issues with box cutters, but typically the bulk of the issues comes from inadequate design to accommodate box cutters, to accommodate decent falls and sizes of box cutters, and it's completely understandable why that happens so much. Is because you've got to have some decent falls in your box cutter, and typically when you're talking about box cutters, certainly in a commercial sense, you have box cutters that run for very long runs, and so if we now just to briefly summarise, and we'll go through it in a bit more detail. If we were to size up a box cutter using the Australian standard, I can't remember the number off the top of my head for that, but using the Australian standard for box cutter design, it's a whole series of, you go through tables, so you work out your location, rainfall intensity, and then size of the roof, and then gives you a box cutter, but then you have several options as to width and height of the box cutter, and that changes things in the table. So you go back and forth a bit. You end up establishing your size of box cutter. Let's say we go with a 450 wide by 150 tall box cutter. That's not the only accommodation that we have to make in that roof. By the time our box cutter gets from this point through to here, let's say we have a 1 in 200 fall. If that's over 20 metres, we've got to have 100 millimetres fall in that time as well. So our 150 millimetre top of our box cutter, we end up having to accommodate 250 millimetres for that box cutter. Accommodating 250 millimetres at times can be difficult. So, because what we have is we've got, say, a detail like this, we've got the rafters come down a bit lower than that, rafters coming down here like that, and then they'll continue down to whatever, and then we've got our support for box cutter under that, and then got to have our purlins on here. Now 150 millimetres, that's reasonable, but once we start going to 250 millimetres, to accommodate our fall, then we've got fairly long cleats, etc. So the accommodation of a box cutter which starts up at this height and then ends up at that height over only a 20-metre run and 150 millimetres high, that's pretty low box cutter as well, just means that you've got to pick your sheeting up quite high. And so it's understandable that people under-design box cutters and that they install box cutters without significant fall. But also there's that. Then there's also people who specify box cutters without giving much consideration to the fact that there has to be significant fall on those box cutters and not sizing them up correctly. So previously it's been a fairly laborious task to do that because they've had to be designed in accordance with the Australian standard. But in recent years, some smart cooking, I don't know who it is, but it's very handy. They've put, I've got it up here, online box cutter calculator. Well, it's really cool. So what do we got? So www.roof-gutter-design or design.com. So if you just did a Google search for design of box cutter AS3500 Part 3 or just AS3500, it comes up with this online box cutter calculator, but it's also an eaves gutter calculator, it's a downpipe calculator, it's a rain head calculator. So they've taken all the information from the tables within the Australian standard and compiled that into a fairly simple program where you just input your data and it calculates it for you. So it makes it much easier than the really laborious process that I learned the tape. But correct design in installation of box cutters is extremely important, because when box cutters overflow, they don't overflow anywhere but inside the building or inside a roof cavity, and that's why they get poo-pooed a bit. But they do make various different architectural solutions possible. Also, with box cutters, it's good to design several outlets. So if one outlet gets blocked by a plastic bag, for example, water can rise up and then go out another area until that obstruction is cleared. So, being part of the roof, they must also be insulated to comply with thermal requirements with respect to excess heat loss, thermal bridging, and the risk of condensation. So there has to be accommodation under there for insulation as well. And I'm pretty sure if you look at the box gutters here, on the underside of these box gutters, they're all insulated at the base of their box gutters as well. But probably as Kane, you would maybe see on sites, doesn't always happen as well. Don't know if you.
Yeah, well,
yeah.
It's a bit like the condensation on a roof. If you don't change the temperature under there, it'll drip. And
yes.
They used to just do plywood a lot, but now they seem to do that. Like that sheet.
For the supporting. Yeah.
Super deck close profile, and that stops it as well.
Yeah, carries some of that condensation. Yeah, but the insulation, I noticed it's mandatory to specify that insulation is carried under the box gutters and so on. But quite often, you see in factory settings or so that it's insulation's everywhere else except under the box gutter.
We don't have any of ours either.
What's that?
We don't have any insulation on our box gutters.
Yeah. So but I was just sort of identifying that as there's the one thing that happens in the drawings and the specification, and sometimes another thing that happens on site. But in cases, not all cases, but wide enough and sufficiently strong to allow foot traffic during installation and maintenance to comply with with installation, to comply with health and safety regulations. So some box gutters are designed to be trafficable, others are not designed to be trafficable, but they should be designed to be strong enough at least to install. So that's at TAFE here. So that's going on the sawtooth roof there, and they've installed that insulation under the box gutters already in that scenario. So the main principle of design of box gutters is to avoid potential for blockages which would prevent free runoff of water and possibly cause water to enter buildings. So several ways of doing that. One is to ensure the box gutters are high enough that at the end they can flow out over a rain head also, or provide several outlets. Also, what I see a lot on hay sheds, probably because I work a lot next to hay sheds, but it probably happens on a lot of modern industrial buildings as well, are those sloped rain heads with the mesh filter on the top. Has anybody else seen those for the exit of box gutters? I think they're pretty good. Well, very very functional design. So a lot of your residential rain heads, let's say you've got a bit of a funky architectural rain head, look like this sort of thing, and then you've got downpipe there, and then in behind that you've got your box gutter sort of terminating at that level like that, and this area fills up with water, providing a bit of head pressure to get it down the pipe there, and then if that fills up too much, well then you've got your overflow hole there. A lot of the rain heads I see on hay sheds. There we go. I'll go right. I'll squeeze it right in here, and we're looking at this side profile, actually shaped with a sloping top like this. So sloping mesh top like that. Yeah, still have the hole Actually, no, I'm not sure if they all have the hole there for exit. But then your box gutter finishes there like that, and the water flows in via that sloping mesh top. So it's great for hay sheds because you get hay and all those sort of blown around stuff on the roof. You're getting plenty of debris in your box gutter, so that debris continuously gets left here on the mesh top where it dries and goes away. So you don't get, the obstruction of things like this with, bits of hay and all sorts of debris and stuff like that. So a very safe way of exiting a box gutter. The whole end of the box gutter is open. And I think it doesn't actually look too bad. It's something I wouldn't be too adverse to having included on a residential project either. So to avoid potential blockages in the box gutter, be straight. Don't have any bends in the box gutter. Have a constant base width and vertical sides. Have a longitudinal slope between 1 in 40 and 1 in 200. So you're not allowed to change the slope, so the slope has to be constant throughout. So 1 in 40, that's a very steep slope. Obviously 1 in 200, that's your minimum, which is the bulk of what gets designed to. To discharge directly into rain head or sump at the downstream end without change of direction. So minimum width of box gutters for commercial or industrial construction is 300 millimetres, and for residential construction, minimum width is 200 millimetres. Yeah. Anything less than that is getting pretty tight for cleaning out. So I'm not sure if that recommendation is for commercial or residential. I'm fairly sure that's for commercial. So minimum base width is 500 millimetres for valleys. And then our box gutters behind parapets, minimum width of 300 millimetres. So various different box gutter shapes and designs. I haven't actually ever seen. Well, I guess that's fairly common. One thing, and it's in the notes on Moodle, or on one of the links, is that you're not allowed to do V gutters anymore. And so what a V gutter is it's like a box gutter. I don't have a razor here today. It's like a box gutter, except goes down in a V like that, where that's where it's tighter than 45 degrees. So it's a less than 45 degree angle. Is that? Yeah. No, that's more than 45 degrees. Yeah. Actually, I'd have to check what the actual minimum requirements are. Yeah. Anyhow, you're not allowed to do gutters. Well, I'll draw it a bit more accentuated. You're not allowed to do these gutters that have a really tight radius in here, so a very steep V. The reason for that is that you gather lots of muck and everything in there, and that bit rusts out really quickly. So, not allowed to do those. This sort of thing, the angle box gutter is fairly common. Box gutter with upturns is fairly common. This one I haven't seen before. Has anybody seen box gutter with a stiffening rib in the middle of it? Yeah, right. Industry guides to good practice allow also recommends an additional freeboard over the maximum water level to allow for splashing of waves up to 75 millimetres. So that's a fair bit. It's a lot, and I dare say that's one of the things that sort of gets cut down a lot on as well when people are trying to squeeze box gutters in. So if we had our 150 millimetre box gutter, had to add another 100 millimetres for fall from one edge to the other, and then another 75 millimetres to that. What are we up to? there we're up to 325 millimeters already. So stand up from our rafters, that's a lot. That's a lot of distance for such a short box cutter. So I dare say that not many people are doing that. But the whole thing of freeboard, that just means just additional height. So the term freeboard, that comes from boating. So a boat that's in the water. Yeah. So I've got our waves here like this. Our boat in the water. That area that sits up above the water is the freeboard. So it simply relates to that. So it's a extra bit there beyond your wall height. So method, actually, won't go into this. I'll just briefly run through this really quickly because, as I said before, there is that online box cutter calculator. So that just makes it so much simpler. The method to design a box cutter is as follows: determine the catchment area drainage to each downpipe. Determine 5-minute duration for a 1 in 100 year interval or recurrence interval. So the rainfall intensity. Select the width and slope of the box cutter to suit the building layout. Determine a maximum depth of the box cutter. Determine this minimum depth must be used for the full length of the box cutter. You just charge it to a rain head. The required size of the downpipe for the box cutter is determined. It says do that from design charts in ASC 500. Sizing principles to limit the maximum capacity of the downpipe in order to prevent slugs of unstable flow. So if we were to quickly duck into our online box cutter calculator, and various different scenarios presented there, but just go simple one with a rain head. Can anybody think of what the roof catchment area for assignment 3 is? Has anybody calculated the floor area for that? I think we're around 250 square meters for our roof area. So we'll go 250. Roof slope in degrees. What sort of roof slope should we put on it?
Less than 10 degrees, isn't it?
Less than, oh yes, much less. Yeah, I'll go. What's that?
1 or 2 degrees.
Yeah, I'll go 2 degrees on that. Cockpit over a roof. It's 5 degrees. Yeah, but we're going to go thick block or spandex or something like that. Okay, therefore, the slope should be between 4 degrees. Therefore, the number. Okay, that's fine. What sort of slope do we want to go to? Minimum? Go to 1 in 200? Let's try. Oh, actually, did we get to put our? No, we haven't put our address in here. So 450. Right, so where is our location? Oh, sorry. Let's do it in Adelaide. Great. So that's not too onerous. So minimum box cutter depth, 134 millimeters. With our slope, minimum depth, 156 no slope. So yeah, and downpipe dimension of 140. So that's fairly achievable. Use a 150 down part for that. So there we go, it's given us our rainwater head dimensions, depth, length and width. So since we got such a shallow box gutter, we can go, oh okay, well maybe we don't have to go 450 wide. Actually, what's our minimum for commercial? 300. So let's go to 300. And so minimum is 157, but we need to accommodate for that fall over the run. And that's still not too onerous. Go with that, calculate rainwater head sizes. Okay, I've got to put in a down part still 140, so we'll go 150 down part. And we've got our box gutter and rainwater head, and then generate PDF the above calculations, and then stick that in the file. So incredibly simple process as opposed to going through the table forms. So some useful information in this. Well, it gives us our rainfall intensity for wherever we want, where we're designing. So that's for Adelaide. So it's 100. Actually, is that rainfall intensity millimeters per hour? Millimeters per hour. Let's say, where do we want to go? We'll go to Darwin. See what the rainfall intensity is there. So Darwin, 380 millimeters per hour. Calculate our box gutter size. Flow is greater than code rate allowable 16 litres per second. Code grass is not goes beyond that point. So let's try. Try box gutter, okay. Try box gutter width 600. See if we can do that. No, still greater. So there we go. So we had to reduce our catchment area for our box gutter to make it actually possible for Darwin, and there, so reduce that 110 square metres. Then we've got our box gutter size. Once again, not to that's right, I'm 600 millimetres wide though. Let's go to 450. Okay. 450. Yeah, not too onerous. So it gives you those limitations, but so there's handy information there for you for various rainfall intensities and so on about the place, if that's important to Although intensity for other places, okay. Because what we don't have in there, for example, is our rainfall intensities for, say, Yankalilla or Nuripur or something like that, because obviously our rainfall intensity is different from Adelaide for those areas as well. So you have to explore finding rainfall intensity for other areas. So yeah, as we saw in the table or in the box cutter calculator before, for a rain head, the flow can't exceed 16 litres per second. So there are those limitations. So the box cutter calculator pulls you up on that. Yeah. So note that AS3500 says overflow devices or measures shall be installed where overtopping of the roof drainage system could cause significant monetary loss, property damage, or personal injury. So basically, you have to have some sort of overflow mechanism, because with pretty much any box cutter scenario, that's going to be the case. So these are our design chart examples. We won't go through because it's fairly onerous, and there's the online box cutter calculator. Also included on Learn is the Strummer PDF for flashing details for various different standard flashing designs. You can fairly much design any flashing you want for any scenario, but Strummer have got a PDF which has been included on the Learn site there that includes standard details for bends, etc. of flashings. This particular detail, or that parapet detail, I think I've drawn that for you before, where we've got parapet wall, parapet flashing, a parapet capping, our secondary parapet flashing that sits under that parapet capping and then folds over into the box cutter, and then an anti-splash flashing there to help stop water coming back into the roof space from blowing water, etc. Also within that detail, so we've got our box cutter support. So that's that ribbed profile you were talking about beforehand. That helps our box cutter stand between supports. So we've got our various different hangers for the box cutter. G'day. In this scenario, we've got a roof truss which is designed to take that box cutter, and that's a typical sort of detail that you get within any sort of residential parapet wall scenario where you're dealing with fairly small spans, and you can utilise timber trusses to make those spans, and then you accommodate a box cutter in the back there. Then our insulation underneath the box cutter, so the insulation to be the same as the rest of the roof insulation. For your standard residential projects in Climate Zone 5, you're going to have an R5 insulation there, so possibly that's what they've got. We've got 2.5 there, and possibly another 2.5 underneath that. Then this detail, it includes what's going to have a downpipe out from that box cutter into the rain head, exiting that way. Typically, though, your box cutters discharge into a rain head directly into that. This detail's got one perpendicular to that. So that's fairly standard detail. But as I mentioned before, with a lot of box cutters being under-designed, because, see, in this scenario, we've got that box cutter sitting right above that bottom chord of that truss. And so that's the height you would end with. But as you go sort of 20 metres up the building, you're going to have to add another 100 millimetres height to that. How you accommodate that in such detail, I don't know. What you need to do is add 100 millimetres to our purlins here to keep that roof consistent and be able to have some slope on the box cutter. But that's a fairly standard box cutter detail behind a parapet. So box cutters must be supported by roofing materials that can span the appropriate spacing. Spacing is determined by the style of roof setup. So that's for timber trusses, so a typically residential scenario. This box cutter strap, that's more what's used in a commercial setting. Either you have the straps, or some of you may have seen on box cutters previously where you have threaded rod hangers. Has anybody seen that detail before? Threaded rod hangers. That's I don't have an eraser here in this room, unfortunately. Yeah. So our threaded rod hangers, they're, I guess, a little bit more agricultural or simple in their engineering, or made of more common components. You have a threaded rod like that, which might have a hook on the end. However, that's located at the top. So threaded rod, and then you have typically a 40 by 40 equal angle with a hole in it. That threaded rod goes through the equal angle. Continue that further on. And then a nut on the base underneath that equal angle that enables you to raise or lower it. And then your box gutter decking material sits on top of that. So that sort of hanger scenario enables fine adjustment of that box gutter throughout its run. So we can start with the much further back with our equal angle up this height, and our decking underneath, and the box gutter sitting up there, and then adjust that down as it goes through. Some rules of thumb for box gutter hangers. So bracket suitable for design for water depths up to 300 millimeters. Bracket spacing is 1,000 millimeters maximum for gutter widths up to, or for spacing widths up to 800 centimeters. But that depends on your decking underneath, the strength of the decking and your substrate, your support underneath. Reduce maximum bracket spacing to 800 millimeters or 900 millimeters width, 575 for 1 meter widths. Or reduce the design water depth in proportion. So that relates to the amount of weight those brackets are designed to carry. So some bits and bobs there for that are on site here for the installation of the box cutter. So use the link to the box cutter design calculator. You're required to design a box cutter using the box cutter and rainhead water calculator. The roof catchment area is the total of all horizontal roof areas draining to all sides of the box gutter, including half the area of any vertical faces that may run off into the box gutter. So we've been through that box gutter calculator tonight, fairly simple. You guys can muck around with that to your heart's extent. To heart's content there with that. But one other thing I will show on there is go back. In that last question on learn there, it said using half the area of any vertical faces that may run off into the box gutter. There is also the ability with this to do more complex box gutter calculations with that as well. So box gutter and rainwater head and box gutter allows the vertical faces and catchments on both sides of the gutter. So there's the option to muck around with that run that box gutter calculator as well. Also within there, a few other things. So pipe size calculator and an eaves gutter calculator somewhere. Where are we? Overflow calculator for eaves gutter. So plenty of things to muck around with, to design, but they're very simple and straightforward for when you have to size up gutters for various different scenarios for on your house designs, etc. Now, you were coming in to ask questions about the materials and methods for diploma.
Yep.
Yeah. Do you mind You've got a bit of time. You mind sitting through this other stuff as well?
Fine.
Cool. Okay. Cool. Or were your questions fairly quick?
No, probably not.
Not.
Probably just a bit of need to have a bit of a just touch base and go, hello, I'm a complicated person.
Right. Okay.
So I'm happy to sit through. Yeah.
Okay. Happy to sit through.
Yeah,
okay.
All good.
Cool. All right. So, but remember, none of this applies to your assignments because this is a.
No, I'm just going with
thing.
this as random information that is interesting. So.
Yeah. Great. So that's box cutters, etc., and calculation of those. So also what we're going to go through tonight is the energy component for task 3. So has anybody had a bit of a look at this yet?
I'd look at the Excel sheet, but yes, we can go through this.
Right, okay. Kane, you had a look? No. Right. So, as you probably know, we use electricity in watts, but when you get your electricity bill, it's expressed in kilowatts because we use electricity typically in kilowatts or kilowatt hours. But one kilowatt hour that equates to using 1,000 watts over a complete hour. So if I was to get a 100-watt light globe and then run that for 10 hours, I'd end up using 1 kilowatt hour. That's fairly straightforward. And so although typically if we were to go buying some light globes at the supermarket, we'll look at the wattage, but also we want to look at the lumens those lights put out. Previously with your standard incandescent light globes, so the ones with the little filament on the inside, it was, do you buy a 25 watt globe, a 40 watt globe, a 60 watt globe, a 100 watt globe, because they were all putting out about the same amount of lumens per wattage. Now things have got a little bit more complicated with a lot of different, more energy efficient light globes that they all vary in their lumens per watt output. So now there's a lot more information on your light globes when you go to purchase them from the supermarket. And what you need to look at now is just the amount of lumens you're wanting out of your light fittings. So an efficient lamp will produce the same amount of lumens with less energy compared to an inefficient lamp. So is the term lumens new to anybody or foreign to anyone? Right, so you guys, Kane, you haven't seen lumens? Haven't looked at that before?
Lumens, no.
No, okay. Yeah, so go, next time you do have to go getting some light globes for home or so, or you're going to cover it all in here tonight anyhow. But yes, lumens, that's about the amount of light which is actually expressed or produced from that light globe fitting. And that's going to be important to us because, well, we'll get to it right now, because there is an Australian standard, or there's an Australian standard for everything, but there's definitely an Australian standard for the lighting that's required within workspaces. So AS 1680 for workplace lighting, typically, or the thing we're most concerned with is the amount or the lumens that are put out by the lights. But there are many other aspects we've covered in the Australian standard, and g'day Dina, many other aspects that we have to, or that lighting designers have to consider. And lighting design is actually relatively difficult. There's a lot that goes into that lighting design. We'll cover a little bit of that tonight. So there's the colour temperature of light, be it cool or warm. That's the frequency of the or actually no, I'm going a bit beyond what I know. But there are various different frequencies of light emitted, and there's the spectrum which goes from warm to cool lighting. So you typically your warm lights are your incandescent light globes that produce a warm light, and your cool lights are your fluorescent light globes. So much like what we have up here. So colour, contrast and reflectance of desktops is considered. Reluctance of other surfaces such as walls and ceiling. Glare is considered. Distance between globe and the surface is illuminating is an important one in determining how many lumens a light globe needs to be. And also the tasks being performed. So let's say somebody who's working in a truss manufacturer's warehouse, they're not going to have a huge amount of lighting. It's not a particularly detailed task, but somebody who's grading diamonds for carats, they'll want excellent lighting scenario, a lot of light on their workplace. So the various different the illumination is set out here in this table. So let's have a look at the range of different tasks. So those lumens as they are at the desktop is measured in lux, and that's how it's presented in this table. So interior is rarely visited with visual tasks limited to movement and orientation. Requires only 40 lux at the workplace, at the work site. What we're dealing with here is continuously occupied interiors with moderately easy visual tasks with high contrast or large detail. So that's more what we're sort of dealing with in a drafting office or a typical office. So around that 240 lux. And then, so areas where visual tasks are extremely difficult with extremely small detail, 1 to 2 millimeters or tolerance, or low contrast visual aids may assist. Wanting a lux around 1200, so for the far more detailed work. So graphic arts inspection, hand tailoring, fine dye sinking, inspection of dark goods, extra fine bench work, etc. And then right at the end of the scale, finished fabric inspection, assembly of minute mechanisms, jewellery and watchmaking, 1600 lux at the desktop. So 1600, what's that? It's going to be about 7 times the lighting required in your standard office. So how do we arrive at that figure of lux on the desktop from our lumens produced from our lights? Because we have a distance from the light source to our desktop, there's a reduction in the lighting intensity over that distance, so that has to be accounted for. We have to account for the number of lamps and the lumens per lamp, so the total amount supplied, and coefficient of utilisation. So that's expressed within this formula here. So illumination in lux is the luminance per lamp multiplied by the coefficient of utilisation multiplied by the light loss factor and divided by the area per lamp per square metre. So does get a little bit complex, but it is certainly simplified for you in this context, in that we have the worked example here for a very standard office, which is probably not too dissimilar from your task 3. So we're after 240 lux at the desktop, and we have an office space of 250 square meters. So this is a worked example. It's not going to be exactly the same as in task 3. You're going to have different area of the workplace, and you're going to or through this process, you're going to work out how many lumens are required in that workplace, and then specify your light globes. So we can work through this example. So what we have required is 240 lux, and we know our area of 250 square meters, and we have, what is that? Our coefficient of utilisation is 0.6, and our light loss factor is 0.8. So we can utilise those in our calculations. So then, expanding that out, or extrapolating that, we end up with 125,000 lumens required in the office.
So that's just following that formula. So the lux is obviously 240.
Yep.
And then the L is your luminance per lamp.
Yes.
And then your coefficient is your 0.6.
0.6.
Yeah.
And light loss factor
is your 0.8.
0.8.
And then you divide it by the area per lamp, which is your 250.
Yes, exactly. Yep. Yep. So with our task 3, we can go with the same coefficient of utilisation and the same light loss factor for that, and we're going to want fairly similar lux at the desktop there. You can have a look through the table and see if you want to specify anything else, but that's our standard office, and that's what I would recommend for that. Yeah, so 240 school chalkboard charts, meaning woodworking, food preparation counters, transactions, etc. Moderately difficult, but routine office tasks, e.g. reading, writing, typing, inquiry desks. You may want to bump that up to 320 for your office space. So we have this chart here, lux required at the desktop. So in task 3, specify what lux you've gone for your office space, and state why. So then, to achieve that 125,000 lumens, we then have to think about our number of light fittings and how we can achieve those lumens per light fitting. So then we have a look at our various different light globe scenarios, see what lumens they produce, and then divide our 125,000 by those to see how many fittings we will need. So we'll go from there to our energy calculator. So within our energy calculator, we're given 2 scenarios. Is that visible for you guys back there? I might make that a little bit bigger actually. don't see the ability to zoom in on the table. So, no. It's adding. Is that visible for people? You can see that well enough. So we have two different scenarios for our energy calculation. So it's comparing a standard office space without the energy saving accommodations or considerations. So within here we have utilising 60 watt fluorescent globes. So we have our 125,000 lumens we have to achieve. We can look at the lumens produced from a 60 watt fluorescent globe, and then put that in there, so work out how many we need. So we divide our 125,000 by their lumen output, specify our number, and then specify what their wattage is. Well, that's going to be fairly simple. That's going to be 60, and then that will tell us how many of those. So let's say 1200mm long fluorescent globes we're going to need, and then we can look at the lumens produced from a low watt LED. So do some research on low watt LEDs that are for sale. So typically Philips is a good one. They produce a lot of low watt LEDs. Have a look what they've got on offer. Then see what lumens each of those light fittings produces. Find out how many light fittings you need. Put the wattage into that table, and you'll get a comparison of wattage used per year and cost per year from the table. So we need to work through that calculation. With air conditioning systems, typically it gets far more complicated, and you typically employ an air conditioning designer to do your air conditioning design. Within this, just to cover the concept and include the concept in the energy calculation, it's been made very simple. So with our more complex scenarios, what's considered is the size of the room, but also the number of occupants, because people give off heat, they contradict the cooling power of the air conditioner, and that air conditioner has to take into account extra load for extra people. The climate of building location, so that can be whether it's a climate that has high extremes or high temperatures, but it can also take into account the humidity of a location as well. The building fabric, walls, roof, and floors, and of course the insulation of that building. So some of the things that are being considered there for the building fabric are thermal mass and the impact of thermal mass, and how appropriate that thermal mass is within the building, whether it's helping the air conditioner by stabilising the air temperature, or whether it's a very solid west facing wall which is taking in a lot of heat and then emitting a lot of heat into the room. So it's about the building fabric and the impact of that, but then also about how much heat is transmitted through the walls. So what are the R values of various different materials and insulation. Also ceiling height. So our ceiling height, so we have the size of the room, we have the ceiling height, so we have the volume to be air conditioned as well. And also ceiling heights will impact on the requirements of heating or cooling system, because heat rises. And so if we have particularly high ceilings in an area that we're trying to heat, we're going to have to provide more heating to that room to accommodate for that. So they are the factors that are considered for more detailed analysis of air conditioning systems. For this task, we're not required to do that. So we have it set out. Actually, I'll just go through this quickly. So within our calculator, we have air conditioning inefficient and air conditioning efficient. In that box, that's the only one that we have to determine. So that we determine by working out what the air conditioned area is going to be. So we have to think about the floor, we have to look at the building plans, decide on what the floor area is that we want air conditioned. So calculate that, but also provide a brief description in your report to say these are the areas I chose to air condition and say why, and then you can give your square meterage in there. So have a look at the floor plan, go, okay, these are the air conditioned areas, these are non-air conditioned areas of our building. So general size of the system is quantified by the output energy. The very general guide is approximately 140 watts per square metre of the conditioned space. So that's what we're going to use. That is not the energy which is used to run the air conditioner though. It's a way of quantifying the cooling or heating power of that unit. So for an office space of 250 square metres, 140 watts by 250 is 3,500 watts. So we've got 35 kilowatt output energy of that unit. But that's not the actual input energy of the unit. So the energy is not the amount of energy required to operate the system. Energy required to operate the system is referred to input energy. The bigger the difference between the input energy and output energy, the more efficient the unit. So for a 35 kilowatt output energy unit, an inefficient system will use the same amount of input energy, so 35 kilowatts to run. An efficient system might use as little as a third of that amount, so an input energy of 11.6 kilowatts to run. In my other class, for the daytime class for c4m materials and methods, I've actually got somebody who designs air conditioning systems, and he mentioned that yes, theoretically you can get on the market now systems that run efficiently as 11.6 kilowatts for input energy, but another factor that they consider in their air conditioning design is lost throughout the system before it's delivered as well. And so he said there's not a system yet that can actually produce that efficiency delivered. So it's producing that efficiency at the unit, but not actually delivered to the room. So, but that's, once again, that's for the people who actually design the systems, which is actually a fairly complex process and beyond the scope of what we do here. So, so our various different systems. And if we go back to our calculator, we've got a system. So to produce 140 watts per square metre of output, our inefficient system is going to use 140 watts per square metre to produce that, whereas for our energy efficient system we're using 35 watts to produce that.
So really, we just need to work out how many air conditioners you need for that space.
Well, no, it's about just working out what air conditioned space you're going to require. So it's about looking. So all you're required to put in there is the square meterage of that space required for that. So work through the plans and determine which areas are going to be air conditioned space. And also within that building floor plan, you've got a server room as well, or at least one server room. They're typically going to have their own air conditioning system because they're going to have different requirements for heating and cooling for that particular bit. So personally, I wouldn't include that in my calculation for air conditioning of the rooms, because we're going to have separate systems for that.
So do we need to do one of these sheets for each of the levels, or is it just one?
It's for each of the levels.
Yeah.
Yeah, so it's a total, but that should be fairly simple to work through, because you go, okay, we've got this level, we've got that many square metres, this level, that many square metres. Yeah. And that's it's fairly simple to calculate those square metres as well. Just by hand.
Michael, are you able to go back over that lumens?
Yeah, for sure. Yeah. So what we've got there is we've got the formula where we're asking for 240 lux. So we have our known variables, and for this I'm not sure exactly where Belinda got our coefficient of utilisation and the light loss factors from. So we'll take those as a given for our standard scenario. So basically all you're going to be required to do, so once that equation is, I can't remember the term for using algebra for when you try to find an unknown from a set of givens. Well, we have a set of givens, but we're trying to find out what the lumens is. So we extrapolate that equation out to our lumens, equaling our square meterage via multiplied by, actually we've got 250 lux there, we're only up to 240 lux. That's something I hadn't noticed.
Yeah, I saw that, and I was wondering it had 240.
It's disappeared, and then
Yeah.
I tried to divide 240 and 250. It didn't come up with 0.48.
No, so that's a mistake. So that should be 240 lux in there. So our total lumens. So our 0.48 is 0.6 by 0.8. That's how we get our 0.48 underneath. So is that making a bit more sense then? That was the bit.
I was trying to work out how it came to that, so that I can do it, and then
sorry, I hadn't.
240 disappeared. So
Yes, I hadn't spotted that before. So thanks for that. I'll have to see if I can get that PDF back into a Word document to change that. So for our example there, if you want to go with 320 lux in your office space, and so we can supplant that 250 by 320 for your calculations, and then determine the square meterage of that office space that you're lighting. Computers get a little bit more complex also. There are more energy efficient approaches to computing systems, so a bit more energy efficient than what we have here. But the complexity comes from the processor is the piece of equipment within a computer that uses the majority of the energy, and how hard a processor is working determines how much energy that processor is taking up. So really the efficiency or non-efficiency or inefficiency of a system derives significantly from what that computer is actually being used for. As designers, I guess, essentially, if you were to know what a space is exactly going to be used for, or typical work use is going to be, then you can design those sort of systems and work out those sort of systems. But for the purposes of this task, we're just after average use of computers, and you can get that information on the internet. So for comparing various different systems, you can get average use of computing systems. So you can get average uses for a specific type of laptop, or an average use for a specific type of desktop. And that's what we're concerned with in the calculator. So within our calculators, we've got 90 computers and a 250 watt rating for our inefficient systems, so for our average use. Have a look at various different configurations, like laptops, dual monitors, or laptop and single monitor, all that sort of thing, to see if you can find an average use computer which is going to be less than our 90 watts running power, which you should be able to do. Also, within office spaces, there are refrigerators running. So within the office dining room, etc. So we're asked in this to find a suitable refrigerator and put that information into the table. So power consumption of refrigerators and freezers is not simply based on the initial power requirement of the unit. Factors which affect the power consumption include quality and insulation of materials, seals, compressors, and other components. So consequently, as refrigerators are on all day, every day, the annual energy consumption of the product is expressed as kilowatt hours per annum. Refrigerators are compared by their size measured in litres. Similar size units should be compared unless the decision to choose a smaller fridge is possible. What we are asked to do with our refrigerators for that component is have a look at what is the best 500 litre no freezer 2-door refrigerator. How many stars and what energy is used each year. So that's a question that you have to answer, and that's done through this link. So use the energy calculator on the energy rating website. I'll see if it opens from this PDF. So we go fridges. And then have a muck around in there to find your 500 litre 2-door fridge with no freezer and the energy and a 5-star energy rating. See what you can find in there. So we're also asked in this to have a look at the solar panels, and one of the requirements is to calculate the number of solar panels on the roof. So we'll flick down to the bottom. So this is not actually our building, so you'll see from your building. But we have a standard size of solar panel, which is 750 millimeters by 150 millimeters. So 750 by 1500. Sorry. So 750 by 1500, and you can configure those solar panels any which way you wish. So
do we need to draw this, or?
Yes. Yeah. So I think that the easiest way to do it is to draw on AutoCAD. Does everybody have access to AutoCAD or Revit or some drawing program? Yep. Kane, do you?
Yeah.
Yep. Yep. Oh, yeah, that's right. You're doing this at the moment, aren't you?
I've got it for 3 years, so
Yeah. What's that?
I've got it for 3 years.
Okay. Yeah. So have a muck around. That's the easiest way. You can also do it you can just do it manually as well, or even conceptually just using maths to do it. But it sort of makes it much easier for you to have, I find, to have that roof space in front of you. So you've got the plans on Learn doing that. So assignment 3 drawings. So we have our roof there, but we can grab those dimensions from the floor plan, get our dimensions of our roof area, but basically we're dealing with the roof area of that shape and working out how many solar panels we can get onto that roof. One of the smart cookies in the other classroom suggested that the parapet wall provides 200 millimetres of shading at winter solstice. So he said that, you know, if this is the northern elevation, you want to set those panels off by that distance or have stand-up frames to achieve better efficiency. Muck around with that if you wish, but I don't expect you to. The calculations are taking into consideration that space and fitting that many panels onto the roof. So yeah, so see how many you can get on there in various different configurations.
So how many configurations do you want?
Oh, just the one.
Just
So
one, yeah.
so the one that gets the most
Yep.
gets the most panels on there. Although there are some limits to the configurations. One of the limits to the configurations is you have to have access to the solar panels with a 600 millimetre walkway around every bank of 2 solar panels together. So we can't just fill the whole roof space with solar panels and then have no surface access to those panels. So we want to be able to reach each of the panels. So that means that you can do things like, you know, have one bank here and then 600 millimetre gap, and another bank there, like that. And those solar panels could be laid out in this fashion or in that fashion, like that. Whichever fashion you want, but there has to be a 600 millimetre access gap on the side of that bank of panels. So just some background on the efficiency of solar panels. So solar panels, their output is expressed in kilowatts, so you have kilowatt systems, but depending on the location of that system, you don't get efficient production of energy, also output from that system. So you'll so we've got Adelaide solar panel system with a capacity of 1 kilowatt will on average produce 4 kilowatt hours per day. So we're not producing 12 kilowatt hours or whatever length of our light. We actually produce less than that. Because of you know, clouds and sun direction, etc. But that varies slightly between location. So Adelaide 4.03, but Alice Springs 4.5. Other sunny areas, Oodnadatta as well, and then less sunny areas like Hobart of 3.24. So it depends on where that system is going to be installed as to the output from that system. So one panel can generally generate around 200 watts, which equates to 0.8 kilowatt hours in Adelaide per day. And that has been factored in to the spreadsheet. So underneath, we've got our this one's been populated already. So So one panel, or 300 watts per panel, 4 hours, 7 days, 52 weeks. So that's 436.8 kilowatt hours per year. But as we put the various different figures in here, our requirements are going to change, and it'll tell us how many solar panels we need to produce the required wattage. And yeah, grid versus standalone power. So this is something which this space is changing a fair bit, and I imagine it will change, or it may change significantly in a few years. The main thing that sort of, so I guess everybody knows what I mean when I talk about grid versus standalone power systems. Yeah. Or what's probably going to be a far more common thing in the fairly near future, grid connected systems with battery backup. So the reason for that is batteries are becoming cheaper. The input, so the amount of money you get from your solar panels or from the electricity you produce, the energy retailers are not paying you very much for it. And what your solar panels do is they put power into the grid, you get paid that small amount for it, and then when you take power out of the grid, you pay a higher amount. So there's that imperative for people with solar systems to get some batteries on as well. So they charge up their batteries and then use their batteries through the night when they're not producing power from their solar panels to get not more efficiency, but more better economy out of their panels. So those sort of systems, they're contingent upon whether the battery system's cheap enough to do that, and at the moment they're not quite cheap enough to. So you test the power laws, etc., are not quite cheap enough to their cost is not enough to offset the financial gain from using those systems, but it's probably going to change as battery power gets cheaper, or as energy prices go up. We're probably going to pass that point where there's going to be that financial imperative for people to have grid connected systems with battery backups. So, but at the moment, typically what we deal with are systems that are connected to the grid. And that's where we're putting power back into the grid, or standalone systems. So predominantly in rural areas or areas where people are a long distance from power sources, they use standalone systems. So on a lot of the stations, they previously had diesel generators running all night to power things, and now they use large battery systems and large solar systems to produce all that power. But you get some people, a few people in urban areas that want to have a standalone system, so be autonomous from the grid, and then also people within the hills area, or new divisions within rural areas where it's too expensive to run power cables to the house. So they go for standalone systems. So that fairly much covers it for that energy component. I'll just flick through, make sure there we know. So we've got the solar panels question. So for our amenities lighting, you're going to have to choose a light fitting to provide at least 1400 lumens. Note the model number and type at the end of the report, and there will be 21 lights for amenities. I think that's included in our table. No, we don't have to put the amenities lighting in the table anymore. So that's for comment in your report. So within your report, you have to comment on your solar panels and provide the layout for that, your amenities lighting, so the number or the model number and type of the lights. This is another lighting example. So in our first calculation, we determined we need 125,000 lumens required for our area, for our 250 square meters with our 240 lux. So in this example, the level of light produced is indicated in delivered light output, and they give a range. So it's 3,800 to 4,000 lumens. And so, so how do we calculate the number of light fittings we need to produce the 125,000 lumens? Anybody? Well, it's going to be 125,000 divided by 3,800. So just quickly, so 125 divided by 38. So we're after, well, it says 32.89 light fittings. We don't get 0.89 light fittings, so we go to 33 light fittings. But they have also given a range there of 3,800 to 4,000 lumens. And so if we divide that by 4,000, I think we get a figure of slightly less than 32. So to choose 32 also puts us right in the middle of their range. So you can either go conservative, go extra light fittings to 33, or you can go 32 to fit within that range. Some light fittings would give you an exact lumen output, so that makes it simpler.
So that has to be mentioned in the report as well?
Yes, yeah. Well, no, that goes into the spreadsheet. So within the spreadsheet, with our lighting, we've got, so in the third one down, lighting 60 watt fluorescent globes. We work out how many of those 60 watt fluorescent globes we're going to require. And then for our low watt LED options for our task lighting, we determine how many of those we need and what the wattage is. So this is just that was just the process for determining how many light fittings you need for that.
So do you type in there and save it or something? Do you save that sheet?
Yes, yeah. So you type in the figures, and it will give you the energy calculations, the energy use for that, and then save that, and then print that page to a PDF is probably the simplest way. You can submit that file as well on Learn, but printing that page as a PDF and then just putting it in your report is also a really simple way.
On the same assignment?
Yeah, on the same assignment. So the assignment covers all the structural options, cladding options, and then it's got the energy component, and you've got a couple different questions in there. So those questions went over to our solar panels, etc. And then you can grab that, print that page as a PDF, chuck that, import that into the report as well. So our questions, well, what we're going to have to put into the spreadsheet, also we have to cover computers. So we'll go back to our spreadsheet. So we've got our air conditioning, our computer options, our lighting example for task lighting, and then also specify some low watt LEDs for sensor lights. So you can use your low watt LEDs that you chose to have amenities lighting, and then put in the watt rating of your chosen refrigerator as well. So in your report, specify your refrigerator, specify the number of solar panels, your chosen light globes, and then that's it. And also your model of your lighting, the wattage, etc. So apart from that gap with the 240 lumens, 240 lux versus 250 lux, is that all fairly straightforward? No?
You might get some emails during the week.
Yeah, that's okay. That's okay. I'll be around the place this week to answer emails.
Well, I think all the formulas are there and all that. It's just a matter of
The formula's there, and I apologise about that 240 changing itself into 250. That makes it really quite confusing actually.
Well, that comes whatever you specify for your light. So if the 240 could turn into 320.
Exactly. Yeah.
And that
Yeah.
320 would just carry down anyway, wouldn't it?
Yes. Yeah. So, but we're using our same our coefficient of loss. So those two factors to end up with the 0.48.
Yeah.
Underneath anyhow. So it's only the top factors in that equation which can change. So the lux you determine at the desktop, and the square meterage you work out how many square meters you're lighting up in the building there as well. And detail that
at the desktop.
Yeah, at the desktop.
What do you mean by that one?
Oh, so that was within our table from the excerpt from the Australian Standard, we have our recommended task lighting, so the lux that's required. So our work in the office happens at the desktop. So typically we don't work on the floor or up high. So that calculation is from that distance. And so that's these figures in here. So recommended maintain illuminance. So we might go for 240 at the desktop. That's for schools, etc. So what we are for routine office tasks, etc. Reading, writing, typing is 320. So you might go for 320. But that's where that comes from. So that's I just say it at the desktop because that's typically where we're using the lighting in the workspace.
Yes.
So cool. Any further questions in regards to that?
Where are the questions that it says?
So they're predominantly included later on in the PDF. So there's that one, and then scroll up from that. There's that one. So the lighting. So our questions. We're going to have to determine our number of solar panels, our amenities lighting, and then
So they're all in here. There's not just a
no
list of questions like the other slide shows.
No, there's not a list of questions. So they're embedded within that.
So I just got one more. So in the high energy appliance, lighting 60 watt fluorescent globes.
Mm-hmm. Yep.
Right, you put in your quantity.
Yep.
But then it's asking the watt rating of the appliance.
60 watts.
That's what I thought.
Yeah.
Let's make sure.
Yeah.
So
That should just be in there, shouldn't it? Because it's a bit of a no-brainer. Yeah, but it gets confusing because you think, oh, hang on, that's given in the description anyhow. So yes, we just
So that's still gonna get to that 125,000 lumens, isn't it?
yes,
with
exactly.
that 60 watts.
Or whatever lumens it is you determine. It has to be produced for that office space.
Yes.
And Kane, the other question that's embedded within that PDF was the refrigerator. Determine what 2-door 500 litre no freezer refrigerator meets a 5-star, and what's its annual kilowatt hour usage per annum. So so work through the energy calculator and
You
the link.
make up your own, like, type out a page that says that question, there's your answer, that question, there's your answer, like that, or?
Definitely, yeah. Just include that. The simplest thing is to include that in the report. So you go, you do all your structural stuff, and you go section 3, energy. This is my chosen computers. This is my chosen refrigerator. My number of solar panels, etc., etc. Just set them all in there, and then have your Excel spreadsheet as the last bit there. And also with that Excel spreadsheet, you got also once it's calculated all the values, you're going to have to divide your annual watt requirements by by your number of your wattage produced from your solar panels to work out how many solar panels you need as well. But that's a very simple calculation. So you get all those figures, and then you're asked to work out how many solar panels you need as well. That's fairly simple. Once it's all populated, you get all those figures, and then So how many? Oh, sorry, no, it's not how many solar panels you need. How many years will it take you to pay off the solar panels? Because you've got all the information there. You've got the cost. You've got their energy contribution. So you have all those, and it's just a matter of dividing one by another. So you've given there your total cost of $400 per solar panel. So all those things are calculated for you, and then right down the bottom here you've got this question: how many years would it take for the solar panels to pay for themselves?
There's a typo in the refrigerator page.
Yeah.
What's the bet? 500 litre.
Oh, what's the bet?
What's the bet?
Okay, thanks for that. I'll have to see if I can get the Word document for that, or get it into a PDF. Sorry, get it from the PDF into a Word to change that. So. All right. Well, now we'll just work on assignments and questions relating to assignments. Does anybody have questions relating to any more questions relating to task 3 or so? Yeah. Well, I'll give you a hand with your diploma stuff.
Okay.
Yeah. Work through that.
Just a general one.
Yeah.
So with task 1 and task 2, how we submitted them,
Yeah.
is there are we going to get graded on it, or is it like, because it still says like
Yes.
set up for grading?
Yeah. So I'm still not allowed to give you a grade. Did I tell you about all that? How it
Yeah,
works?
I think so,
maybe
yeah,
I did. Yeah. So there's a whole bunch of new rules that come in, which means that I have to do a certain amount of training before I can attribute grades. I was hoping to actually get that done by mid-May, but it's actually turning out to be a massive amount of work.
Yep.
And so I still haven't finished that, and it's unlikely that I'll get that finished by the time the grades have to be done. So I'll have to get another lecturer to countersign all that. So it's about sorting all that out. So what I've tried to do is provide you all with feedback to say, this is how you're going, and say, nudge, wink, wink, you won't need to resubmit, it's all good, but I can't actually put that grade in there as yet. So I have
is it just like a you've met requirements, or is it?
It is. Yeah, it is just a you've met requirements.
Yep.
Yeah, which is a bit of a pity, I think, because you get some people who sort of go above and beyond and produce some excellent analysis, and then some people that just scrape in and they're just all in the same one. I try to reflect that in my comments, just and I guess you would have got various different comments, so to give you a bit of feedback in terms of your level, but but that's all that's supplied is you've met the criteria, you haven't met the criteria, and if you haven't met the criteria, you'll definitely know about it.
No worries. Thanks.
No worries. Okay.
So, I've staff once.
Yeah.
Yeah. So I can't use what I was saying. So basically, that's
Yeah, right.
Yeah. So I have.
So-
No, that's cool. So I've got 130 students, so it's
Yeah.
so it's a bit difficult to remember who
totally.
said what.
No, that's
so
fine. I think
you-
that's a very minimal. I mean, basically, I'm dealing with some public health conditions that have been absolutely kicking me out, and I'm not keeping up.
Yeah.
So, I just finished off this quizzes just then.
Mm-hmm. Yeah.
I've looked over, basically I've looked at all the assignments and I'm confident I can get them done because I'm working as an interior designer at the moment.
Mhm.
My
Yeah.
background is interior design.
Yeah.
And I work at the Home Idea Centre. So,
Right. Okay. Yeah.
so basically I can get this done. I just can't get this done by tomorrow. And I didn't submit my assignment one.
Yeah. So assignment one's fairly quick and easy.
Yeah, I
You
think
should-
it's about
yeah.
half done, but it got buried under the pile of everything.
Yeah. So that's fine. It's the 22nd is the latest date that you can get
Yep.
everything in, because that gives me a week
Yep.
to do grading, provide feedback. So really
Yep.
within that week, there's really no avenue for resubmissions.
Yep.
So, but you can submit up until that point. So
Okay.
up until that point, I'll still be accepting work and going through it all. So these are the due dates that make it all easy and workable for people who who will submit something, and then there'll be some issues. I send it back to them. They've got those couple of weeks to fix everything up and bring it back in.
Yeah.
You've got up until the 22nd, but beware that doesn't give you any chances for resubmission.
Yeah.
It might be that yes, I look at yours first, and then I say, oh, you do need to fix this up in
Yep.
a day or two, but yeah, you
But
should,
just really try not to
exactly. Well,
get
just
in as soon as possible.
yeah, just assume that if it's close to that date or on that date, then there's really got to be no time.
That's
So
fine. Yeah.
so
good. Okay,
as long as you understand that.
Yep, so I'll just get it done as quick as possible and
Yeah,
just get it to you as soon as I can. Yep.
Yeah.
Second one was with the first assignment, like how it's provide forms or something. So
Yeah.
is a screenshot of the website.
Exactly.
okay
Yeah. So
option?
that's fine. Yes, because so many councils have moved toward having only online forms. So even if you just provide the link, so you say this is the link, but if you can provide a screenshot saying this is the information that's required, that's the best.
Cool, yeah, because it asked me to pop my
And-
details in, and I was like, I don't really want the gas connection people to be calling me saying, hey, you've got an incomplete.
Yeah.
Yeah.
So with all your services, that's fairly simple. You can say these are the people we need to contact for these services,
Do that.
and and the difficult thing to answer, the difficult question in that is it says who's responsible for the trenching and pipe laying, etc.
Yeah.
That's the difficult thing to filter out. What's that?
The builder, do they organise that, or does the services authority organise?
So there's different requirements per service authority, and they're not really forthcoming with that information. Some of that information is a bit buried. So that's the bit that will take you a little bit of time to work out. For example, with electricity, you have to, or you're responsible for everything that's past the service fuse.
Yep.
And so where that service fuse lies, is it, or yeah, exactly. And so typically a modern service, that service fuse is going to be in the fuse box on the building, and the electricity owns then that mains power to your building, but you have to pay for that connection to wherever their outlet is on a power pole there. So you'll your client is responsible for the trenching and cable laying to that point, but it's infrastructure that they don't end up owning.
Yeah, right.
So that's for electricity, but for gas it's slightly different. For SA Water it's slightly different.
Yep.
And but you should be able to find that information on their website.
Yeah, I sort of started to find it.
Yeah.
Yeah, cool, that's okay.
So but that's a tricky bit.
Alright, sure. So the next one, I'm just looking at assignment, the research, portfolio collection, so that's fine. Yeah, so I'll look at that and I'll get this one. So that one and that one, I'm gonna get that.
Yeah.
All three.
So okay.
Alright, that's cool.
So is it going to be easy enough for you to get on the site?
I actually got on the site this afternoon.
Okay,
They're building across the road from us, but I also work with a number of building designers, so.
Okay, right.
And
So
we've
that's
had a
going to
bit
be
of brief chats, but it's just never really lined up properly, so that'll be fine.
yeah. Okay.
Yeah, no problems at
And so
all with that.
yeah.
Yeah.
All right. So no questions about
No,
in regards to all that.
No, that's
so
fine.
that one's
In a couple of weeks, I'll pop into their own site because, because we're doing an apartment.
oh right. Yeah.
For
Yeah.
clients at the moment, so yeah,
Yeah.
that's
A
fine.
couple of weeks might be a bit late.
Yes,
though,
exactly.
for this,
Exactly.
But, yeah. But
Yeah.
okay. Yeah.
No,
just-
that's fine. Across the road, they're building 4 townhouses, and I just popped over there and took some photos.
Oh,
and
yeah,
get the
great.
guys coffee.
Yeah, and if you can, and you'll probably be able to pop back there and
Yeah.
pretty much any given time. So,
Yeah, pretty much.
Yeah,
So
if
that's
you realise, oh, gee, I should have a photograph of that. Yeah.
just right so
Yeah, that's good.
Yeah, okay,
Yeah.
and
So that should not take you long to produce at all.
no,
part.
that
part,
won't.
yeah.
It's
Yeah.
just getting a little bit of time to do that.
Yeah.
Which I should probably do.
Yeah.
And I was going to ask as well. I was told to ask you. Jane Pinion from
Oh, Kingsman.
Kingsman.
Yeah.
Yep. He said to us. Because I saw him on this. I saw like that guest speaker from Kingsman on there, and I was
Yeah.
like, "Hey, buddy, you're doing this thing," and he
Yeah,
was
it's a-
like, "I think I'm doing this thing.
No.
I do this
no.
thing every year. I don't know." So
Oh, yeah. Sorry.
we've
yeah.
caused him a
okay.
panic.
Okay. Oh, no.
He's going,
sorry.
"Have I lost it?"
I'll send him an email and say sorry. Things have just been absolutely mental this semester,
Yeah.
and I haven't been able to organise any of those things. No, I definitely
Yeah.
wanted. Yeah. Because strangely enough, I work for Kingspan as well
Oh, okay,
myself.
yep.
But well, Kingspan Environmental, I do water tank installations and so on.
Yep.
So yeah, so
Yeah.
I've been wanting to actually. So I've been keeping in contact with those guys, but I haven't spoken to them in a while, and yeah, and so I'll send
Yeah.
James an email saying sorry, didn't get you in this semester because things have just been nuts.
Yeah.
Trying to coordinate
Because
everything.
I'm on the desk there, so I've just been
And-
like quietly ribbing him, so being
Yeah,
like,
'cause
so
they're
you,
upstairs.
you forgot? Yeah, they've got the office up there.
Yeah,
Like, so
okay.
you lost your diary? Like,
Yeah. Oh,
and he's just going, oh shit. So,
yeah. No,
Cool.
I'll apologise. Because I
it's
can't.
not
Yeah,
true, don't worry.
yeah. Oh, well, so
I'll see you
basically,
tomorrow.
but basically the reason is that for our I don't call in industry representatives for the night class because night class is quite small and it's at night time when people are home
Yeah,
typically with their
yeah.
families. So I'm not going to go say, hey, you guys come in at night time
Yeah.
for 3 people or 4 people.
Yeah.
But what's happened with the daytime class? That's on a Monday. We've had now we'll have 3 public holidays within this semester. I had to miss another one of those Monday classes for this training. I was meant to miss 2 of them, so that meant there was just very little class contact time, and so I had to use all that class time with the students. So I haven't been able to get. But if you explain that to him tomorrow, that'd be great. But anyhow, I'll send him an email. I'll find his email address and sort that out. Yep.
Yeah. All good. Okay.
Great.
Cool. All right. Well, I think okay, and I'll just keep on
So it's
going with things and get them to you as soon as possible.
Yeah. Okay.
Alright.
Yeah. So that's the main thing. Some things for what is it? Part D research assignment. So that's mostly about collating information, and you'd probably be able to do that at work.
I'll walk around the work. Yeah.
Exactly.
I was
Yeah.
thinking my house is a 30s brick thing, so I don't think I could find any plasterboard there, but I'll go to the plasterboard display.
Yeah. Exactly. Yeah. Or go to the CSR Red Book. I don't know, do you know the CSR Red Book? So
Yeah.
that whole section there about various different types of plasterboard. Yeah. So
We've got
it's
a whole wall of
and
James Hardy.
yeah. And remember, it's a research assignment, so it's
Yep.
not so much about producing that yourself. It's just about collating this information and referencing it. So, say I've got this stuff on timber defects from Wood Solutions, but I've got the thing on plasterboard from the CSL book, and doing all that. So that should not take you very long to collate. But
Just need to
yeah.
timetable it
So
into the
yeah, so
world.
yeah. But where are you at with the various different ones?
Different.
Different assignments.
Assignments.
So
Probably about a third of the way through that one.
yeah.
Half done that. Probably more than half done that.
Okay. Yeah.
Haven't started that.
Right. Okay.
So I think it's doable.
Yeah. Yeah.
It's definitely doable. I
Yeah.
just need to transfer myself.
Yeah. Part D will
And
be
not get sick.
yeah.
Yep.
That's going to be the most time consuming to compile.
Yep.
And yeah, part B, that shouldn't take you very long to compile that one at all. I think do that in 2 to 3 hours max. I don't know how long is it taking you to do half of it.
45 minutes.
45, yeah,
Yeah.
okay, yeah. So 2 to 3 hours
Yep.
max to compile the whole thing of that.
Yep.
Yeah. But this I would give it, or somebody who has access to all the resources like yourself and a fair bit of experience, give it maybe 5 or 6 hours to compile that.
Yep.
Put that all together.
Cool.
Yeah.
Maybe.
And
Put it in
and
by
that
tomorrow.
probably 2 to 3 hours
Yeah.
for that one as
Yeah.
well. So, but that's working fairly solid and punching it out.
Yeah.
But yeah, you've got a couple of weeks to do that.
Alright.
Okay.
Can do.
No,
Okay,
you
thanks.
yeah,
I just
no, you'll
wanted
be
to,
fine.
I just wanted to come in and just be like, hi, I'm not slacking off.
Yeah,
I'm
yeah,
really,
yeah.
really quite sick
Yeah,
at the moment.
yeah.
But yeah, doing
and
that as
yeah,
well.
and find out what the parameters are with submissions and so on, because you know, 'cause
Yes.
some people go, oh, you didn't submit, well, too bad. You,
Exactly.
Yeah, no.
And yeah, it's something that's likely to be long term. So it's just like, okay, just make the application sort of early-ish at the end of the semester, but not 2 days before the due date being like, oh holy shit, because then
Yes,
You're-
well then I'm
yeah.
less inclined to
Exactly,
go, oh,
yeah.
this is going to be a possibility.
yeah, and then I'm permanently just going, oh my god, I caused so much stress. So
Yeah,
yeah, cool.
cool. Yeah,
Alright,
no worries.
thanks
And,
so
and thanks for
much.
letting me know about neglecting Kingspan people as well.
I'll pass it on.
Yeah.
All right, thank you.
Alright, cheers, thank you. Rightio. And yeah, any specific help wanted or so? How are you going with things, Dino? I haven't had much time to. I know you had plenty of other stuff to be sorting out. I haven't had much time to follow up on you because I'm fairly confident you're doing right. But
Yeah, honestly, I didn't get the chance to open the third assignment yet.
yeah,
So
Yeah.
I have no idea actually what's happening there.
yeah. Okay. Well, we can go through that if you like. Have a chat about that. That's fine. Yeah. All right, we'll do that. And how about you other guys? Did you need to talk about some things?
Struggling to
Relation to-
find a fridge.
Oh,
without a
right.
freezer.
Okay. Yeah. Okay. Maybe that needs updating. I'll go through that. I didn't go through that today. So
Are you looking on your iPad
It's
or?
the 2-door that's, yeah.
No, there's a link that you can go to within the there's a link within the PowerPoint.
yes. Yeah.
Oh, what,
Yeah.
on here?
Yeah.
Yes. Yeah. There.
Oh, okay.
Yeah.
It's
Sorry. I thought so it's what is it? It's above the refrigerator, and there's this one, the energyrating.gov.au.
yeah, page 17.
Oh, thanks for that.
Yeah.
No worries.
Oh, that's really good.
Yeah. Good.
You did say that before though. I thought,
I did.
now
Yeah.
you brought that back up, you did show us that, so.
Alright, I'm getting you up this week when I got problems,
Yeah.
alright? You know what I mean?
I'll send you my other assignment 1 and 2.
Yeah.
You can cut and
Yes.
paste.
Yeah. That's
Yeah, no
fine. Yeah. No, that's fine. Yeah. Look, I'm going to be behind in my marking anyhow. I'll be playing catch up, so that's fine. I don't. Yeah. Got no qualms about. Yeah. It's much better that you finish it completely
Yeah.
on the Monday than
Two more.
hand up something that.
So you do that.
Yeah. Yeah.
Yeah, okay. Thank you.
Great. Thank
And
you.
then, so you're looking for a star rating refrigerator, so click on fridge, and then like, click and the stars you want. It can give you the what rating of an appliance.
So good. Powered ahead with that.
I'm
Ready?
trying to.
Especially it's looking very populated.
Yeah.
All right. So with the final assignment, where are we? That's our.
See you guys.
Okay.
See you later.
Yeah. So this is the building, but that, and we've got, so we've got our various different floor plans. So go through that. What we're required to do for this, should be fairly familiar. So assignment 3. This is where scroll right down. So this is where we should be quite familiar. So we've got completion date there, the 15th, 6th. As I said before, I'll probably be playing catch up with marking there as well. So if you need a bit of extra time, that's fine. But be aware that the week after the 15th is the 22nd. After the 22nd, yes, I'll still take, or up until the 22nd, I'll still take stuff and mark it, but it doesn't really give any time for any resubmissions or so if there are any issues. So, but always it's much better to hand up something that's completed and hand it up late than hand up something early that's not completed, because it will take me at least several days to get around to marking it and providing that feedback. You might not see that feedback, and by that time you've got no time to resubmit. So, but if you're really struggling with things, just send me an email and let me know. Probably access my email quite a bit. So very familiar. For this task, you're required to provide a report involving appropriate construction and design terminology, comparing and evaluating 2 structural options, 2 cladding options. And service options, as detailed on the learn site, 3-story office building. So that's what we went through tonight. So
Spreadsheet and all.
that was it. You didn't have any questions regarding that from tonight? Because I can't think of what point you came in. Well, you came in during box cutters.
No, I came in when you were actually explaining the locks and loops.
Right. Okay. Yeah.
So
I thought it was
I didn't get what you were talking about, so I didn't have any question.
Right. Oh, okay. Yeah. Okay. Yeah. Gotcha. Okay. Thanks. Yeah. No, that's good. All right. So we'll go through that. So it's very standard thing, including where pertinent manufacturer detail related to installation of chosen options. The report must include a minimum of 2 details, either self-drawn or sourced from appropriate product literature, and a brief synopsis recommending a preferred structural option and preferred cladding option. So that's a little bit extra in this one. So you have to include some details, but you don't have to draw them yourself. You can get them
quickly go
from
through and
elsewhere.
I'll do that.
So
Then when I go right now,
yeah. So for whatever your cladding option is, there'll be plenty of details online about those.
You went to the link,
for the
Yeah, I'm in
bolts
there
down
now.
concrete floors, there'll be plenty of
Oh,
details
yeah.
about those. So
We
whatever
can just
you
take
get
some picture from as an example and
Because I found one
Yeah,
before,
exactly. We'll just take it from the
179.
internet. So we go,
Two-door.
If you go to the one through here, I might give it easy.
there. So that's for example.
yeah.
So we might want to go to the page that came from to see the context. We're talking about importing details like this. So we can
I think I'm at the stage where I've got this company lights and see how many.
that's if you choose this
Yeah.
panel system.
So you
One
can
thing we went through, not last week, the week before,
and then just go to
was with the use, actually maybe you know a bit about this,
Oh, there's
dealing
and
with
then just go to
compliance.
star rating.
I can't remember exactly
And
what
then
you do for work.
I work in a building company
Yeah,
and directly.
Right.
It's
Okay.
2 door.
Yeah.
Is it two?
You had something to do with
Two-door,
do
yeah.
with
Star,
CFS
right?
or something. Is it? No. Okay.
Oh,
So
yeah, I have,
yeah,
yeah,
I mean, I
previously.
have done work placement
And
in
then,
CFS.
yeah. Yeah.
So then how many litres you
Yeah.
want?
Yeah. And so a major
change
issue
the volume.
thrown up with these. You know about the Grenfell Tower fire in
Yeah.
London
No.
that
Have you
happened
done this
last
before
year?
or not?
No, I'll just play
So there's a
around.
major building in a big residential building in London which caught fire and now it's a big black stuff.
I
And
did single door, so
It's
it's
all
all
over in a
17
minute.
people died in that fire. Yeah,
Thanks for
anyhow.
that, Damien.
So
That's all right.
that's because of this particular type of cladding
So I can do that
as
as
well.
well.
So that's something we went
Can do it.
went through when you were away.
Computer.
There are some major
Yeah.
compliance issues now being
Yeah.
raised about
Didn't
this,
think about
this
that.
type of
Yeah.
cladding. So it's a type of
Just
cladding
saved me
which
half
is
a
used on a
weekend.
whole lot of
I hope it
buildings. But the problem with this
You
is
can
that
have
when it
Monday off,
catches
right?
I
light,
spent all last weekend
this
on
panel
this
will
one.
burn and it will
Yeah,
ignite that
like
panel
that.
and fires race up buildings really quickly, dropping down bits of
saying.
flaming aluminium with
I don't have
polyethylene
weekends at all.
bits on the building setting them alight. So it's yeah. So there's
Monday, Tuesday, Wednesday.
you can still use this on buildings, but
Right.
things are really rapidly changing in that regard. So
basically
I'll just bring that to your attention because
And then last
um,
week was.
it's a very common thing to
Tuesday,
specify, but
Wednesday,
maybe
Thursday.
some of the other students in this
Nine
class
to
after showing them the video
And this week
where
was
everything's
Monday,
at around the
Tuesday,
size of this might not
Wednesday.
solve that. So
But
you-
9 till 1 in the morning.
It takes a while. Let's just
yeah, if you no focus on the assignments, but yeah, just try and draw that conclusion. So
Where we in touch with,
the assignment open there somewhere. Yep. So yeah, so include a minimum of 2 details in self-from or source from approach from another literature and a brief synopsis recommending the preferred structural option. So
you go
cutting
for a steel
option,
frame.
also the structural option say, or after you talk about your two, saying this is the one I think is best.
Okay.
And then same thing for your cladding options. Once you've talked about all the aspects of them, saying this one is my recommended option for the two. So and also include reference this etc. So refer to the building plan and elevations on those as you would be required to do with an architectural design office. Determine a range of appropriate construction approaches and materials via research and evaluation of construction done for construction.
Oh, yeah.
And systems for the low pitched flat roof with parapet wall. So that's designing a very flat low pitched roof. So a metal decking roof and a parapet wall. So we can't use tiles on that. We can't use custom made
brick
cladding because that requires a 5-degree pitch. So we're talking
Yeah,
about
the
original
metal
name in the
decking
UK or
solutions
something,
or
yeah,
some
they
sort of
use it
commercial roofing solution.
It's likely to be expensive.
Walls
Yeah,
may be
every,
a mix of load-bearing walls such as
every
concrete
course of
panels,
brick,
concrete
you've got
blocks,
screw and
non-load-bearing walls, columns,
For
such
every
as clay,
course,
skirting
clip
walls,
them in,
and lightweight cladding
clip the
options
next one in, clip
such
the
as
next one in.
pressed fibre cement
So it
sheet,
looks good,
etc.
and you can go
So
as high as you want.
You can go with
pretty much. I think it's
with a glazed
No,
curtain
you can-
wall cladding solution,
23 stories
if
or
you
something.
wish, or with any reverse cladding system. So that's the same as technical floor system.
Oh, I didn't mind the one
We
that looked
prefer the
nice,
long
but that grey
Guide
one,
for ones back concrete
Just
floors. That's
yeah.
within the load.
like the packing box.
And this is fairly similar to assignment 2. Assignment 2, yeah. So and that should be fairly simple. That's fairly simple. Great. With the extra external load-bearing walls, we can plug into some fire source and just every 9 metres fire source feature.
Columns, floor.
Also common walls, fire walls, internal fire resisting stair shafts. But that's in the table. That should be
Steel
on that
trusses.
easily.
Yep.
And that's all fairly standard. Also no restraints like scarlet materials, etc. It's all very, very standard, very simple. You should understand that. Have a look at these various different things if you haven't already. We covered these in class. So that aluminium sandwich panel, the third parenthesis is that one. Curtain walls, that curtain wall glazing. Concrete panels. So have a look at concrete panels. So not many buildings use them now, but some buildings do that New Flinders University that uses concrete panels and this cladding. But more famously used to what was it called the Festival Theatre on the Torrens, concrete cladding panels. You'll see it on buildings about the place.
But the concrete panel is quite heavier than the other.
Exactly, yeah. So concrete panels are very heavy. Yeah, so require significant construction, and that's why they're not used. Typically, they're only used more for expressing a certain aesthetic or something. I think there's another building on North Terrace which was built not very long ago.
You researched it.
Get the name of that building. But you'll see it on some modern buildings as well. But it's expensive and requires quite a lot of structure to it. Compressed fibre cement sheeting, that actually gets used probably maybe a lot more than many people would expect in commercial products. I'll just quickly. Just system names.
But isn't this just the services? The one missing to it.
But yeah, a lot of fibre cement sheet cladding getting used, especially since there's fire issues around that. Also, Danpalon is another one, which
I think this is the services.
I think you're right.
You got me right.
so that's what Danpalon looks like. That's the material. So it's actually translucent sheeting. So it's this sheeting like this.
Looks like glass.
Well, it doesn't. Yeah, I wouldn't say it looks like glass. It looks like
the panels go.
well, it sort of looks like plastic sheeting. It looks like
you can use
Like
it.
transparent.
transparent.
Plastic.
Yeah, exactly.
Show
Transparent
the span.
plastic.
Yeah.
But it's pretty good. So there's actually a lot of it used on this tape here.
You'll get information on
Yeah, which is not.
Yeah.
Yeah,
Panel
which
from a couple of
isn't instantly recognisable, but we
businesses.
see it used. Yeah. A bit more. So and it's really easy to install. It has these little metal clips that go over that, and then these other clips go over top of that. So you just put them there, you click, put another one there, click. It's really quick and simple.
So it's not that much, it's just a bit different.
Is it quite a new technology?
Just the sleeves.
About 6 years or so. Yeah. So I guess that's pretty new in terms of building. Concrete masonry or
We've already finished it.
Turn to the list.
so, and then services refer to the Moodle site for information regarding services, and that's what we went through tonight. So, you have that open.
Yeah, they don't have to, you can drive up, go to lights or something like that.
This one, yeah. So what we went through. So that's all fairly standard. That I imagine you understand. So electricity is measured in watts. Sum it all up, multiply by the hours, we get kilowatt hours of energy used. Lighting is expressed, or its usage is expressed in watts, but its output is expressed in lumens. And so we need to look at the lumens produced by our various different lights. So, so we've got that's our standard incandescent, old type of light globe. So for 75 watts, it produces 1100 lumens. Well, let's say we'll go. Well, these ones, that one was 43 watts. But not many people use these halogen incandescents now either. They're pretty much past technology now as well. So a lot of stuff is compact fluorescents and LEDs. And so to produce that 1100 lumens, an LED will only use 15 watts to produce it. So what we were going through just before you came in is that there is the Australian standard for workplace lighting, and it's specified how much lighting you need for various different tasks or for various different uses. So, us designing this for an educational institution, we're required to have 240 lux at the, and it's always talked about at the desktop. So 240 lux here where we're working, and how we get to that lux, that's through this calculation, because although that light will produce say 400 lumens, by the time it gets here it loses a lot. So we have our light loss factor, which is 0.6, and then our coefficient of utilisation, so not all of the light gets used or reflected. And so we have, and those are a given. So use those 0.6 and those 0.8 for your assignment. So if we expand that equation to determine the lumens that we need, so L is the figure we're after. We're after, we had 250 square metres. So we're after 250 square metres, and that should say actually 240 lux. So 250 by 240 lux divided by 0.48 gives us 125,000 lumens that we require. So what you'll have to work out for the assignment is how many square metres you're lighting up, so give the total square metres, and then work out what lux you'll require. And so that will be done by looking at this table, going, do we want 240, do we want 320, do we want 400? So have a look at that, work out what that lux requirement is. So multiply square metres by the lux required, divided by 0.48, which is derived from 6.8, and that gives you the total amount of light from your light fittings produced. So that's all we went through before you came in. And then this, was that fairly straightforward for you? That was, yeah. And that's just about calculating the square meterage of air conditioned space you need within the building. So you can have a look at building plans. We went away from these before.
Sorry, Mike, I just overheard you talking about the lights.
Yeah.
It says here a warm white downlight, LED, 825 lumens.
Yeah.
So, 125,000 divided by 825.
825, yeah, gives you the number of light fittings you
for the
need.
floor.
What's that?
That's for that top floor or second floor.
Yeah,
If you work it out that area.
Yeah, for that 250 square metre space, wherever that 250 metre square space is. So, yeah, let's say, for example, that office space is given, one of those floors is 250 square metres. You need it for that, and you need it for the other ones as well. Yeah, that's fairly
151 lights.
right. Yeah. 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 Cool. So you put your 151 in there, and then make sure you write all this down. Yeah. Or you've written it down, you've calculated it, and you've recorded it, I guess. Yeah, so you got your 151, and then then multiply that by the wattage, or put your wattage in there into your table, and it will tell you how many kilowatt hours.
Oh, okay. Yeah.
Have you chosen the? Oh, yes, you did. You spoke about the low watt LEDs.
Oh,
You
I just
already.
looked at. I had no idea how many lumens were in a light, so
Yeah.
I just found out for the first time.
Yeah. So it was 430 lumens or
It's
whatever.
there, so
Those ones. Yeah. And
yeah,
and you can muck around with different scenarios. So go onto light manufacturer's website and see what products they have for what. But it's also it's also really handy just for you for at home as well, for getting your energy use down. It's a bit of a complex calculation to work out the amount of wattage, lumens, and
It used to be, you put 8 downlights in a room because it looks good, but I found putting 2 in a big room, that's enough. Like,
yeah.
if you're working at one end at the table with one downlight on,
Mm-hmm.
it's enough light.
Yeah. Yeah, for what you want. Yeah, and that's sort of where your lighting design comes into it as well. Because for some scenarios, you actually have to use a whole lot more lighting. Like for downlight, you're producing lighting in a certain area where you're using it, and you can get away with using less. But then other lighting, which might be a pendant light, it's less efficient. And it's spreading light all over the room. And
If you start trying to use dimmable switches,
oh yeah,
all of a sudden you're paying 3 times as much for a switch, and then you've got to pay the electrician another half an hour to wire it up and do all that sort of thing. So
and then when you come to buying globes, you have to buy far more expensive globes as well. Don't know if you noticed that before. When it comes to your low watt globes, to buy the dimmable ones, you have to pay for that as well. Because not all your globes are dimmable as well. Your efficient globes.
Then it's different type of light.
Yeah, well, different type of globe in there.
Okay.
So not all globes are dimmable. So we'll say that.
Oh,
So
I didn't realize. I thought the standard light you can just add the dimmable regulator and you can just dim it when you want.
no.
Okay.
No. So
So
that
LED is a bit different, isn't it? Because once they stop, that's it, isn't it? You can't change the globe. Like LED downlights,
yeah.
once the globe burns out, that's it.
Oh yeah.
Yeah.
Well,
You need some. It's normally more money for the dimmable.
yes. Yeah.
You can't change the downlight.
Oh no, you can. You change the globe. Yeah. Oh, is that what you're talking about?
I mean, no. He's saying you can't change that one.
As far as I was aware, LED, once they burn out, that's it.
Yeah, but after that you can take that out from the roof, then you can, and I'm just changing the new one.
Yeah, a new light, like a whole new light.
Oh, yeah.
Yeah, but
That's good.
Yeah.
Sorry.
I reckon the old globes you could just put dimmable straight
It is.
onto those,
Yes. Yeah.
like not LED.
Yeah. The incandescents, they're all dimmable. Yeah.
Yeah.
But the LEDs, some LEDs, you put them into a dimmable switch and you dim it, and they start flashing. Yeah. But anyhow, that's all good.
So with the low watt LEDs, just quick run over it. So it's 125,000 lumens.
Yeah.
That's at the top of it.
Yeah.
And then we've got 3,800 to 4,000 lumens.
Yeah.
So it's 125,000 divided by 4,000, which is 32.
Yeah.
So you're saying, well, 32 lights
Yeah.
at 47 watts.
Yes. Yeah. Yeah. Exactly. Yeah.
I had it at 4,000 before, and I was going, wow, it's like,
Yeah.
I've done it at 4,000.
No. So yeah. So
So
the
$87,000 to run them up.
No, that's wrong. Yeah. So yeah, because the lumens, so that's the output.
Yep.
So the lumens is what's put out, and the watts is what's put in. So
Okay.
watts what it runs on. So watt rating of the appliance is 47.
Yep. So that is the same over here then, isn't it?
Yes.
So
Yeah.
it's-
So they're 60 watt fluorescent globes.
Yep.
Yeah. So
And it's
it's
125,000. What then would be divided by whatever the output in lumens.
yes. Yeah. Yeah.
Right. Cool.
Yeah. Yeah. So how did you arrive at the 150?
I was just playing around with it.
Oh right, yeah. So the way you arrive at that is to just search for while we're here. Search for 60 watt fluorescent globe lumen output.